What we're going to look at now is the erosion and sediment control system design. So as engineers, we're morally bound to try to reduce the effects on the environment, including sediment, the damage that sediment can do, and legally as well. There are rules, council rules and national laws that say that you have to take steps to prevent environmental damage. Now, the way that it's administered in New Zealand is by earthworks consents. So the territorial and regional councils are responsible for protecting the natural water systems, and the way they do that is through consents. Now, in Auckland, the territorial and regional council is one organisation. It's the Auckland Council. In other areas, you might have a regional council. So, for example, there's the Waikato Regional Council, and it covers several territorial councils, Hamilton City Council, Waikato District Council, and so on. So that's the way it works in New Zealand, and the way these people are entrusted with protecting the natural water systems, and they do that by demanding consents. You need a consent to do earthworks in New Zealand, and they set conditions on those consents, and one of those conditions is that you install erosion and sediment control measures. Now that might be practices that you're going to do. You're going to open up only a limited part of land, and also things that you're going to install like sediment ponds and silt fences and so on. And they also monitor compliance with the consent conditions. They will come on site, they have inspectors, they come on site and they make sure that you have done those things. If you have not done those things, or if you're not doing it properly, or if you're polluting the stream, they will close you down. They have the power to stop you from working until you fix the problem. So the erosion and sediment control. So with the consent application, you go to the council, you make a consent application. You have to have an erosion and sediment control plan, ESC plan, and it's required with the consent application. It's saying this is what we're going to do to make sure that when we're doing our earthworks or our whole project, that we protect the environment or provide an adequate level of protection to the environment. And it sets out how the erosion will be prevented and how sediment will be prevented from entering the systems. Now that seems like quite an onerous sort of thing, but they are not only the policemen, they are also the guides. So they provide some very clear guidelines on what they expect you to do. It's not like they expect you to guess what they want. They've set it out very clearly in this document in Auckland, GDO5, Erosion and Sediment Control Guide for Land Disturbing Activities in the Auckland Area. If you do what is in this guidelines, if you propose that, if you base your erosion and sediment control plan on this document, then you will be meeting their requirements, and if you implement it properly as well. So it is active now, so sorry this was a bit late, and it's technical guidance. It tells you how to design it, how to use it, and how to implement it, and how to maintain it. It used to be called TP90, and it's very similar to TP90, so you might find some of the old timers talking about TP90. So the heart of the of GDO5 is these 10 principles. So the first one is minimize disturbance. So when you're designing, try to minimize the amount of earthworks that needs to be done, the amount of area that you're opening up. The less area there is, the less soil there is to be eroded, and the less sediment is going to get into the stream system. Stage the construction. So once again, that's minimizing the amount you're disturbing. So if you've got a 4-hectare area, if you can divide it into two 2-hectare areas, so you do one area and then you reinstate it, you put topsoil and grass back on it, and then do the next area. So you're halving the amount of area that's exposed to the elements, and obviously you're reducing the amount of erosion or the amount of sediment that can actually get into the stream. Protect slopes and watercourses. So try to minimize the amount of erosion that happens. So you can see there's a 2-step process here. The first one is try to avoid erosion happening or minimize erosion. You're not going to stop erosion from happening, but you minimize it. And the second thing is, when erosion happens, you're collecting the sediment and treating the water before the water goes into the natural water system. So it's a 2-step process. You install perimeter controls and diversions, so you try to minimize the amount of run-on, which is the water, rainwater that runs onto the site. You employ sediment retention devices. In other words, you try to pick up the sediment before it gets into the natural watercourse. Need to be trained and develop experience. You need to adjust the erosion and sediment control plan as needed. So if you're on site and it's not working, and you see that there's an excessive amount of sediment getting to the stream, you need to re-look at what you're proposing, because it's your responsibility to make sure that you are implementing proper protection to the environment. Number 10, assess and adjust it as needed. So what we're going to look at in the next few videos is this design process. As I said, it's a two-step thing, and it's not either or. You do this one and then you do that one. So it's erosion control, minimize the erosion, and there's several ways of doing it. Minimize overland flow, minimize flow velocities, protect the water channels, and stabilize and protect as soon as you can. And the second one there is sediment control. Sediment, even if you try to minimize erosion, it's still going to happen. Sediment is still going to be produced, and your job is to pick up that sediment before it gets into the natural water system. So that's what that second layer is about, is preventing the sediment getting into the streams. So you remove it from the runoff and you retain the sediment on site, and then you let the clean water go into the natural water system. So this chart here is really quite useful. It shows a summary of what we're going to be covering in the next few videos.